We've just hit the industrial age of AI, and the real issues really show up at scale. You don't really get the luxury of thinking about these constraints that you don't otherwise have unless you're dealing with large companies and large data sets. Right now, when it's moving so quickly, if you kind of spend the time, you checkpoint at a particular point and say, hey, I'm going to go now theorize about this or think about this really deeply. By the time you come back a few years later, that paradigm has completely shifted.
For the last 20 years, we've built observability tools around one assumption: a human being is looking at the dashboard. What happens when the software becomes too complex for humans to understand and the primary consumer is another AI agent?
If all of the code is being increasingly written by AI systems, all of the logging standards are being created by AI, that specific human may just not be able to understand it because they didn't write the code. And so understanding is dropping, the systems are getting more dynamic, and this particular way of thinking about the health of your system is no longer going to be very viable. In the future, I think it'll be an AI that will kind of decide what it found important, how to kind of store that information so that it knows to look at it in the future. All of the data processing, the index and querying of observability data is going to look different. We fundamentally believe this is an AI problem. It's not an observability problem. The job of engineers will be to manage agents. Thinking about observability, thinking about reliability for agents is going to be quite different as well.
Anish, for the last 20 years, we've built observability tools around one assumption: a human being is looking at the dashboard. What happens when the software becomes too complex for humans to understand and the primary consumer is another AI agent?
Thank you. It's a great question to start things off with, and I think really at the heart of the problem. One is all of observability was about making your system observable, and you can actually visualize it and see it through and look at it. The way that has actually happened is through dashboards. So dashboards at the end of the day are some sort of enshrined query, some sort of query that people have decided is important and they want to visualize it and look at it. And so it's a predefined cut of the data that we've decided is something we should look at. I think the analogy of an ICU is a good one, where you have someone in a bed and they have all of these different sensors going into them, and you'll have maybe 10 or 15 of these different sensors that are going to be important all the time: heart rate, blood pressure, things of that form. And they give you some sort of sense of the health of your system. Now, what has happened is that as the systems have grown more and more complex, we have more and more dashboards. But there's only so much context that any one person or even team of people can keep in their head. Even though you might have 10x more dashboards, the amount of context you can keep in your head still remains the same. It doesn't scale 10x. So that's one problem that we're feeling. Second is that these systems are so complex that it's unclear that even if you could put a dashboard into everything, these systems are so dynamic in some sense. The dashboard is something you've decided is important, from looking backwards. But these systems are so dynamic that the way they break in the future is very different from the way they used to break in the past. And now, so that's the second problem. So a dashboard is a good view of what happened in the past. It's not a good view of what's the way it's going to break in the future in a novel way. The third problem is that a dashboard fundamentally assumes that some human can understand what is being written and what is in that dashboard. But now if all of the code is being increasingly written by AI systems, all of the logging standards are being created by AI, even though you might have the perfect dashboard in front of you that explains what went wrong, that specific human may just not be able to understand it because they didn't write the code, they didn't write the telemetry. And so understanding is dropping, the systems are getting more dynamic, and these things basically mean that this particular way of thinking about the health of your system is no longer going to be very viable. Now, actually, already, we've already seen that with our customers over the last 6 months. And I think increasingly over the next 6 months to a year, it's going to become fully untenable.
Let's talk about the company you're building today and where you're at today. Why did you start to think about this as a problem worth solving?
Yeah, so I'm the CEO and co-founder of Traversal. We're building an agentic SRE platform. This category is called AI SREs. So SRE is short for Site Reliability Engineer. So SREs have been tasked with the job of building resilient systems and along with that, operating these systems. So when incidents happen, alerts happen, figuring out what went wrong, the troubleshooting of these systems and keeping them reliable is what SREs do. And so what we're doing is essentially building an agentic version of that to help troubleshoot for this new age where the complexity far outstrips what any teams of SREs or engineers can do. So that's what we're building at Traversal. We've been around for about 2.5 years now. How did we come to this problem? It's interesting. We in some ways are real outsiders. So I come from the world of research. I'm a professor at Columbia University, and my co-founders and I, we met at MIT where we were doing our PhDs. We were all in the CS department. All of our research was broadly in AI and ML, but we focused on a few areas. So one of the areas being causal AI. So as we know from the world of observability and operations, correlation is in causation. correlation. And so our research, these AI systems are very good at picking up very fine-tuned correlations in data, but they're not very good at reasoning about cause and effect. And so our research is how do you get these systems to learn about cause and effect relationships from data? That's what we studied. And then along with that, reinforcement learning, which is essentially how do you search large spaces effectively. And so those are some of the areas that we worked on. And I moved to New York to become a professor. I didn't really have an intention of leaving academia. I thought this is not that I've left academia, but of like doing anything other than academia, because I just wanted to be doing the most interesting research. And I think what happened was that with ChatGPT coming out about 2.5, 3 years ago, it became clear to me that we've just entered a new epoch where the most interesting research now, is actually happening in companies with research in their DNA taking on super technical problems. And so that was my motivation for starting the company along with my co-founders. But we started without an idea, but we had a clear sense of the type of problem we were looking for. So something at the intersection of our research in Causal ML and RL and how it fit with agentic systems. And this was way before agents were really a thing, but we kind of had a sense of this is where it's going. And we went through a few different ideas. And our fourth co-founder, he was from Citadel Securities, and he basically pitched us on the problem because you can imagine uptime is super important for a firm like Citadel or anyone in high frequency trading. And as we looked into the problem, it felt like we were designed for this problem. We just never heard about it before. It was like almost like this, it's like a spark where it's like, oh my God, where has this problem been our whole lives? And because at the heart of it, it's like you have this, complex system, like a software system that is a complex network. And when one thing breaks, it spreads like an epidemic and everything looks like it's broken, right? And so figuring out is a given issue a symptom of the underlying issue, a spurious correlation because something else is wrong or the root cause. It's like finding a needle in a haystack with fake needles everywhere that are throwing you in the wrong direction. And that's exactly what our research was about. The haystack has like logs and metrics and traces and code and config files because the LLMs are landing. And at the large enterprises, it's about a petabyte of data being produced a day, if not more, multiples of that. And so you need an agentic system to search through it because it's too large. And so in terms of the wave of technology that is happening in the world and what we are particularly good at, this all fits super nicely. Obviously, observability is a big market. It's just ripe for change. It has to change given the amount of like AI code being created. So all of the things came together in about April, May of 24, and we've been on our way since.
So it's just really interesting and fascinating. You have quite a unique and special and prestigious academic background, and being a professor, not thinking really about starting a company, you found yourself starting a company. What's more interesting is something you just said there, which I was going to ask you about. You said, or at least what I'm understanding is some of the most amazing breakthroughs happening now with this new AI movement is not in the universities, it's not in academia, it's in the startups, it's in technology companies. Why do you feel that's the case?
I think one is we've just hit the industrial age of AI. As a result of it, this is the time where we're trying to bring this to the world at industrial scale. And when you think about industrial scale, you're thinking about power, you're thinking about inference, you're thinking about compute capacity, and the real issues really show up at scale. And so I think you don't really get the luxury of thinking about these constraints that you don't otherwise have unless you're dealing with large companies and large data sets and things of that form. So I think that's one part of it. Second is I think academia is well designed when you get to sit and think about a problem for a long period of time, right? And so I think I think academia is important, will always be important, but I think it will be at a time when things slow down again and things coalesce and we have a bit of time to like think about it and come up with frameworks. Right now, when it's moving so quickly, if you kind of spend the time, you checkpoint at a particular point and say, hey, I'm going to go now theorize about this or think about this really deeply. By the time you come back a few years later, that paradigm has completely shifted. And so one is the scale and the constraints that only show up at scale. And the second is the pace of innovation is such that it's not really the time to build frameworks that will last you decades. It's time to just kind of do, and then we'll reflect, maybe 5 years down the line once these things have settled a bit more than they have. So that's probably my theory.
And as you're building AI that is tackling site reliability engineering world, what happens to SREs?
I think the way I think about it is that I think healthcare is always a really good example. So if you think about the Maslow hierarchy of needs as it relates to health, if you're having a heart attack, right, that's all you're thinking about, right? You have to go figure that out ASAP, right? Every second counts. And then you have the second part of it, which is you have some chronic conditions that are affecting you that, your neck's aching, your thumb sprain your foot, whatever, right? So and then you're kind of dealing with that all the time. And it's like 1,000 cuts that are constantly kind of affecting you. And if you can deal with these two things, then you have the luxury of thinking about, it's called like biohacking, where you're thinking about longevity, how do you improve your overall gut biome or whatever it might be. I think that kind of analogy can be applied to SRE as well, where dealing with an incident like a SEV0 or SEV1 is like having a heart attack. Dealing with like the SEV3, SEV4 is dealing with those alerts that are coming in all the time. That's like the chronic conditions. And then you have things like, I'm trying to build more resilient systems that's going to be dealing with the infrastructure load that'll come over the next 5 years. That's like health hacking and biohacking. Now, towards your question of what is going to happen to SREs, I think right now the world SREs live in is they're having basically 3 heart attacks a week and they have like 5 chronic conditions. And, maybe on the weekend they get to spend a little bit of time biohacking. And so I think what our goal is to take away the most painful parts of the job, which is troubleshooting of these complex incidents, and then the daily operational toil that you have to deal with production, which is, making observability a little better, like triaging alerts, etc. So that all of that operational toil that we want to go automate all of that away, along with making the underlying data systems that power this also reinvent that. So that leaves time for SREs and engineers to be spending their time building resilient systems, architecting resilient systems, which is the type of work they signed up for in the first place. And so I think that's really where the more higher order work is really where we want them to spend time. I actually think the opposite thing is right now happening in the world, where, engineers, for example, think that they should be, they get to go build everything and do all the cool work because AI is writing the code. But what we're seeing more and more is that AI is writing the code, but then it's given to the engineers to review it and actually like deal with all of the issues that show up in production. And so they're more and more doing the less interesting work versus the more interesting work, because once it hits production or it has to get reviewed, our hope is to kind of turn that scale back to where they can actually do the most creative work.
Do you think that responsibilities such as on-call requirements for SREs, is that going to go away?
It's going to be dramatically changed. I think the world in which, I'm already seeing this, but the world in which you have like 50, 60 engineers in a war room, it starts with like, incident commander, and then he or she says, hey, like, maybe it's the database group, and then like they bring 5 or 6 people in the database group, everyone starts panicking. They're like, no, it's not the database group, that this is a symptom, actually we should go to this application. And they're like, no, it's not that application. Then you go to the next one, and it keeps going on and on and on, and you have like the 60 people all asking who done it, saying it's not me, no, it's you. And then like maybe at some point it all kind of comes together and they have like this magical moment, or one person who's been there for like 20 years has that magical moment, like, that's what it was, and you figure that out. I think that world should not exist and will not exist. So I think what will be the case is that an agentic SRE platform like Traversal will certainly handle most of the incidents, and I think actually can heal the incidents too. We're already seeing that, where it's a full platform from detecting these incidents, so stopping them from becoming massive before they do, almost like an early warning signal. If there is an incident, then find the root cause and then actually self-healing the system. And then I'd say where the SREs may come in is really as verification, maybe before you heal the system, for the team that is relevant for that, or the collection of people that should verify the answer before it actually fully self-heals. That's one place. And then maybe the most complex incidents would be a place where you probably want someone to have a look, right? So I think it'll be an agentic SRE's job to give confidence levels for the different root causes it finds. And for the ones where it has less confidence, it pulls in a human just at the right time with just the right context. But rather than 50, 60 people, it should be, 1 to 5 people at any given time maximum. And so I think that's the way it will change. And then I think the other place maybe SREs will show up is as we think about how do you build a resilient system as you learn from an incident or 5 incidents and say, hey, okay, one is remediating the system in the real time, like, you pull back a PR, you change re-provision some infrastructure, whatever. But then there's the long-term fix so that this type of issue doesn't happen. I think SREs will probably come in there as well to like really do like deep postmortems and deep RCAs to figure out how do you make the system resilient in the long term. I think that's another place they'll probably show up.
What are your thoughts on dashboards? Are they going to become obsolete?
I think, what are dashboards? A dashboard is a enshrined query that says that, hey, this was important to me at some point. So next time something happens, at least I know I've earmarked this as something to possibly look at. I think dashboards are useful as a way of giving a warm, in some ways that is the best version of tribal knowledge we have, is dashboards, because that is kind of a sense of like, this is the things that people have decided are important at some point. So it gives you a warm start for an AI to go start looking for things. So that's one. In the future, I think it'll be an AI that will kind of decide what it found important, how to kind of store that information so that it knows to look at it in the future. I don't think that will be a visual dashboard. There will just be other kinds of enshrined queries versus like a visualization of a dashboard. And that has important implications because I think a lot of the data processing systems that are in place right now, they're designed for like really good UI UX as it relates to a visual dashboard, right? So making sure that the refresh rate on the dashboard is really nice. You kind of can see it moving up and down and it feels very dynamic. I think those kinds of things are going to become unnecessary because those things are helpful for an engineer to have a nice UI UX, but an AI doesn't care about like a super high refresh rate on a specific dashboard. It wants to look at a lot of data at the same time. right? So I think the all of the data processing, the index and querying of observability data is going to look different because you don't need this kind of high refresh rates, but you need to be looking at dollar data in parallel. And the idea of earmarking certain kinds of data so that you know that's where to look in the future, that will continue to be the case, but that won't be a human creating this dashboard. It'll be an AI deciding that for itself and storing it in a way that is particularly representable or readable for the AI.
I'm fascinated about this because my background as a recruiter up until more recently has been the SRE DevOps infra world. You know, that became such a big market during 2015, 16, and so on. And it makes me wonder, is there going to be an evolution of what this role would look like in the future? What engineering would look like in infrastructure, in SRE? Are there going to be roles like SRE researchers? What do you think the next 5 years is going to look like for this market of infrastructure?
The SRE research is an interesting one. So I think that, we have we're proud to say we have the world's first SRE researcher at the company. And, he's part of I spent a good amount of time with the research team. He was an SRE that been an SRE for many years, and part of why we were really excited by him is that he was able to troubleshoot a bunch of incidents from first principles. And when you kind of take some of that knowledge, you bring that to AI. There's some interesting things that happen there. I think some of the most interesting companies get built when you get people in a room that otherwise have no reason to be in a room together. And I think having a bunch of PhDs in CS and statistics sitting in the same room as SREs, I don't think is something that typically happens. I do think that's interesting. And I think that kind of change in organization is going to probably happen throughout engineering and infrastructure, where I think software engineering is becoming, I think, a lot more statistical and AI based. And so you're going to have a lot more, I think, researchers embedded. The way you have SREs embedded into different teams, I think you're going to have researchers embedded into different teams that are thinking about how do you automate these different workflows or make them particularly well suited for AI to help add productivity. So I think that's going to happen for sure. And then I think, this is somewhat of a trope now, but I think it's reasonably true, which is that the job of engineers will be to manage agents, right? And so design agents and manage agents. And so I think that'll be really interesting for sure. And I think out of that will come interesting new problems as we think about infrastructure and observability, because these systems are inherently far less, they don't operate in the same way that humans do. And so thinking about observability, thinking about reliability for agents is going to be quite different as well, right? And so I think a lot of the infrastructure and observability engineers and SREs are going to be thinking about reliability for agents as well. And I think how that is going to look like is going to be interesting. And I think we're very much in early stages of that too.
Love it. Anish, I want to take it to your role as one of the co-founders and CEO of the company, and you've had so much success. The company's doing so well. Firstly, there are some incumbents in this space. There's some players in this space, pre-AI. What are your thoughts on, I guess, why they haven't thought about solving this problem? Maybe they are now, but why didn't they tackle this market initially? I've got some other questions about how your role has also evolved from being a professor and how you've seen this major growth in AI. But just going back to that, why haven't the incumbents tackled this problem early on?
So I think it's a few things. One is, at the heart of it, we fundamentally believe this is an AI problem. It's not an observability problem. And so you need people like us to be in the space to solve the problem. And I think the type of talent that I think we've had the fortune to have at this company, I think has been unique. And I just don't think it's easy to get that talent to show up at an incumbent 20-year-old observability company in terms of AI talent. And the way you think about the problem is very different, because we think about it from the perspective hey, if we build this from the ground up and you had AI agents doing everything, how do you rethink the entire stack? And I mean literally the entire stack, from the core data layer, right? How observability data is stored and indexed and queried. How do you rebuild all of that when agents are querying the data? And so we have the luxury of thinking about redesigning the whole stack right from the ground up because of this generational change that is this AI reasoning engine that sits on top of it. And it just wants to look at data in a totally different way. So I think that's the second luxury we have that other people don't get to have. They've been in the space for a long time. And I think the third is that, as a startup, you have the right to win in a market if it's very fragmented. And I think observability is, despite being one of the largest markets, right, software markets, it is one of the most fragmented. And so especially as you start going up market and you start working with companies that are larger, they're using every observability tool under the sun, right? So whether it's Datadog or Dynatrace or Splunk or Elastic or Grafana. And so they're using everything, right? And ServiceNow. And so The problem is that you can't get all of the answers from just one part of from one of these tools, because typically the incidents that people care about, the buyers care about, it'll be that, hey, some users can't log in, they can't pay something, whatever it might be. But then that's a symptom. The issue might be like 10 hops down in the bowels of some database somewhere, right, that is running slow. And so to do the hops across different from the UI, the checkout API, to the specific applications, to different layers of the infrastructure, the telemetry being created from each of those different parts of the system are being emitted to different observability tools. And so you have to be able to build something that looks across all of these different things. Now, the way these observability tools look at data is the way they price is fundamentally based on the data they're looking at. So they're very incentivized to give you insight only if you bring all the data to them. But that's just not going to be possible in this world because it's already so fragmented. And I think no one wants a vendor lock-in in that way. No large enterprise wants a vendor lock-in that way. And so that's why I think for us, where we don't price that way, we don't look at the world that way, we want to sell you basically the outcome versus like anything else. We can kind of look at all of these systems cohesively and give you like a real answer that is much deeper. So that's like a market reason why it's hard for them to win, along with the earlier reasons which I said, which is just that it's an AI problem, not a auxiliary problem. And so the talent, and then getting to redesign the entire stack from the ground up.
How much of the success of Traversal has been centered around the density of the talent in the company?
I'd say that's all of it in some ways. I think a startup is really a collection of people on a joint mission. I think we've had the good fortune of having a very talent dense environment. I think it's a few different things. One is I think people really love this problem. I think we love it as researchers. Engineers love working on this problem. It's something that all of them have dealt with, and it's in some ways the worst part of their jobs. And so troubleshooting in an autonomous way is something that they're passionate about. I think also, as I said, this problem requires you thinking we're really at the frontier of what is possible with agents and with data and with infrastructure. And so I think it's cool to the complexity of the problem they have to handle is fun. And I think getting to be solving a real tangible problem for a specific company, and also being at the frontier of what I'd say is research in agentic architectures, in some of the statistical methodology. I think that's a cool feeling. So you kind of have the feeling of being a bit of a lab, but also being in like an enterprise SaaS company. And I think that's an interesting mix, a unique mix, I'd say, that very few companies get to enjoy. So the density has been something I'm very, very proud of. That's the heart of it. That's all we got in some ways.
Yeah, the reason I ask is the talent and the execution. When we talk about the incumbents, the engineering behind that is different, bringing a different flavor of people into the business. A research flavor, as you said, AI problem more than anything else. But also, it makes me wonder, as you said, it's an interesting problem, because when I think about all the SREs I've worked with over the years, they do burn out because of the tension around the on-calls, as we discussed, and you're solving that for them, which is definitely something that is powerful in the market. One last question I want to ask you, Anish. Going from academia into the startup world, that transition, and then seeing the scale and success of a company, how has your role changed from being a professor to being a founder to evolving to becoming hopefully larger, successful startups? How has that role evolved for you?
I'm having the time of my life. I think it's an absolute privilege. I pinch myself every day that I get to do this. And in terms of the role, I'd say in some ways there's a lot of analogies between being a professor and running a company. A lot of it comes down to, I'd say, taking the very complex concepts and simplifying it for different audiences for different kinds of reasons. So, like if I think about the role of a CEO, you have, I'd say, three fundamental roles. One is recruiting and recruiting well. The second one is selling, right? So your customers can understand the vision of what you're doing and where you're going and how you want to partner with them. Especially when you sell to large enterprises, they're a lot of times looking for a partner more than just like a point vendor. And the third is fundraising, right? Which is where you're now telling the vision, painting a vision for venture capitalists. And I think there's in some ways a similar kind of thing happening as a professor, where you have to write grants and raise money so people you can run your research vision. You have to recruit PhD students and then you have to be able to give talks to your peers to explain to them what you're doing and to get them excited about your work. And so a lot of it comes down to like really good, compelling storytelling and simplifying of complex messages into things that people can emotionally resonate with. And so that's been really wonderful. I think the parts I've had to grow at, I think, is just the pace. I think, especially in this age, the pace in which these companies move is astronomically quick. And so learning to move at that pace and being able to make decisions with far less data with a lot more uncertainty, and just getting comfortable with your intuition, I think has been a place where I've had to learn. And I think even in the last like 3 or 4 months, my role has changed. We now have like a full executive team. We have a really world-class head of engineering, a head of sales, a head of field engineering, a head of marketing. Just making it work, in this new role is interesting in its own way. And I feel like every 6 months, the company has changed so much that the way I have to manage, the way I have to motivate people is fundamentally different every 6 months, with the one continuous thing being like good, clean storytelling.
I love that you said that, because I was just going to say how much of the role is storytelling versus actually engineering. Because when you talk about the 3 traits, the recruiting, the selling, the fundraising, when you wrap it all around, it is storytelling. Whether you're talking to a potential new hire, whether you're selling to a customer or selling to an investor, you are effectively telling a story. How much of your time do you feel has been storytelling versus anything else?
Storytelling, but storytelling in a way that I fundamentally believe in it. So but yes, I'd say a lot of it is storytelling. The other part of it is, I think, making decisions, right? I think that's another key part of the job, is being able to decide with little data and kind of make decisions and then mostly be right. I think that's really important. That's the other part of it, I'd say. I think sometimes the worst thing you can do is to have inaction in these times. Like, you have to keep moving. And if you get paralyzed, if I, on the one hand this, on the other hand that, what happens if I had more data? What happens if I wait another 2 weeks? You're done, right? So I think that's the other part of the job, that the outside storytelling is like efficient decision making and mostly being right.
Absolutely. Anish, it's been a pleasure. I really enjoyed this. We wrap every single episode with a book recommendation, and I'd love to get one from you.
I think good book for people who are willing to nerd out a little bit is this book called Mostly Harmless Econometrics. It's basically about how do you, a lot of learning causality. The best way of learning causality is running an experiment, like running an A/B test, running a clinical trial. These are all ways of learning causal relationships from data. A lot of times you can't run these experiments. They're too expensive, or they're just fundamentally infeasible. And so you're looking for natural experiments that are happening in the world to be a substitute for running an actual experiment. And this book gives you a framework for thinking about that. I think that's a very interesting way of just thinking about decision making with data and hunting for natural variation in the world. And I think that framework is important, certainly in our world, in the world of SRE, but in general as well.
I love it. Anish, it was an absolute pleasure. I've really enjoyed this, and hopefully we can do it again in person, maybe in a couple of years or in a year's time, see the progression of the company. Massive fan of what you're building. And thank you so much for being on the show.
Thank you, Faraz.
Thanks, Anish. Thanks for tuning in to another episode of Inside the Silicon Mind. This podcast is powered by Harrison Clark. For more episodes, don't forget to subscribe and hit that notification bell. As always, stay curious, stay consistent, and stay inside the Silicon Mind.